And welcome everybody to the Daily Space Weather. Today we'll be talking about new sunspots which have formed in the northern hemisphere of the sun, the cold Pacific Ocean, and the electrons are back, but most importantly, also a coronal mass ejection, I believe, is occurring as we made the video. We won't get too in-depth into it as it hasn't propagated enough to show you great imagery of it, but here's some great imagery of the sun. And there is activity going on down here in the southeasterly portion, down in that area. And again, this is something to keep an eye on throughout the day. And when I say eye on, well, the pun is intentional. So this is 335 angstroms. Here's 171 angstroms. As well as the colorized magnetogram, you can see sunspot 2799 setting in the northwest, and two active regions there, right in the Earth-facing longitudes north of the solar equator. Some more cycle 25 sunspot behavior. The 10.7 centimeter radial flux has actually dropped down to 76. There's a one-year chart of the radial flux. That one is available at solen.info/solar. That's SOLEN.info/solar. And there it is in context with sunspot number. Welcome to Cycle 25. Welcome to the Neo-Renaissance. And welcome to the Daily Space Weather. Let's see what's going on at Lagrange point 5, which would be this one down here. The location of stereo A. And we see only a tiny little shakeup right at the end of the video here. Not enough to really make any calls, but there is a little bit of activity kicking off. And you can see that is in the southern portion of the sun. And for new viewers from Lagrange point 5, the Earth would be out in this direction. And let's move on to look at a chart of the solar system. Here's where things are now. There's where things will be tomorrow. Looks like a full moon. And there's where things will be in a week on February 3rd. Here's a star chart. If you're up before dawn, you may see the moon setting. And in-the-sky allows you to even animate your star chart if you like. Where will you be when Venus rises? Well, it'll be rising before the sun at a magnitude -3.9. And let's get to a couple HelioViewer movies. We'll save the best ones for last. Here's 304 angstroms. And I would note the filamentary activity in the southeast, which would be your lower left. And for aesthetic purposes, allow me to vanish. And here's the magnetic environment of those two new sunspots. It looks like sunspot 2800 and 2801. And they'll have to be there for more than 12 hours to get a name. I saw umbre when I did show prep. We'll show you by the end of the video the newest high-res images. Here is 193 angstroms, which gives you a good view of a coronal hole in the south and the north. And we'll show you one more at the beginning. Here's that northern latitude region. And those two bright regions actually did show umbre when I did show prep. And let's continue on with some more data here. And we'll bring things a little bit closer back to home, here to planet Earth. See what's going on with volcanoes. And what's going on is Etna is continuing to be active. There's an image of Mount Etna, possibly heading toward another explosive eruption. a paroxysm, Europe's most active volcano. Will there be more lava fountains? Who knows? But don't fly your hang glider over the caldera. It could be unhealthful, and we need the views on YouTube. Next, Merapi, also exploding. 40,000-foot ash plume there. So big uptick at Merapi as it's producing a 40,000-foot plume of ash over the central Java island of Indonesia. Yowzers, a major uptick at Mount Merapi. Dacono, also erupting, 5,000-foot plume there. Popocatépetl down in Mexico, 19,000-foot ash plume as it explodes. Fuego explodes as well, 16,000-foot ash plume in Guatemala. Sangay in Ecuador exploding as well, 20,000-foot ash plume above that. Volcano and Sabancaya is producing continuous emissions of ash. A reminder to not attempt to pole vault the caldera. That could be unhealthful, and again, we need the views on YouTube. Next, looking at the life of the stream. And thanks again to our Twitch viewers. We are streaming live right now. It's twitch.tv/smAshomash. And while it's not the official streaming platform of the Smash News Network, we regularly stream to Twitch because it's quite good. So no major quakes over the past 24. Looks like nothing over a 6 magnitude. Although some deep quakes continue to occur, such as this 4.6, which happened yesterday at 13:05 Universal Time. It's a 4.6 magnitude near Fiji at 578.8 kilometers depth. Here's a deep quake in the northern Mariana Islands, near the deepest part of all oceans, near the Marianas Trench. Not to be confused with the marinara sauce. Here's a deep quake in western South America. That one's in Argentina. It's a 4.0 magnitude at 128 kilometers. A couple of small deep quakes have struck southern Alaska. We won't get in depth into it. A 4.5 at Argentina is at 106 kilometers depth. So a bunch of deep quakes kicking off here. Also, here's one in Indonesia, a 5.0, one of the largest of the past 24. That 5.0 was at 134.7 kilometers. Here's a deep quake at Japan. Here's a deep quake at Colombia. And happening while we do the show, it's another deep quake at Fiji. It's a 5.0 magnitude at over 570 kilometers depth. Let's check the location of that just for fun. And there you can see it's in between Fiji and Tonga. And that area is indeed the Earth's deep earthquake capital. The capital of the deep earthquakes, folks. Next, looking at real-time solar wind. Allow me to get back off the screen here. And we see a continued elevated solar wind speed. We're looking at a one-day chart this time. Current solar wind density, 7.4 protons per cubic centimeter. Current solar wind velocity, 548 kilometers per second. Again, it's remaining elevated, and we're getting NOAA warnings for a KP of 4 expected. So don't be surprised to see this go back into geomagnetic unrest conditions. That is the KP index, a measurement of global geomagnetism. Currently at 2. So here's some Geospace Magnetosphere movies. We see significant pressure from this continued elevated solar wind, pretty steady here over the past 4 hours, which is the amount of data that these Magnetosphere movies will show. And we show it daily as the archival data is not yet visible. Here are ground magnetic perturbations. And we see significant changes in the Earth's B field here over northeastern Canada, as well as the southern Indian Ocean, south of Australia, where the South Geomagnetic Pole has moved to, and less magnetic perturbations over the Siberian North Pole. I'll let it play through a second time, as there's a lot of information on that one Geospace Magnetosphere movie. And we show this one daily as well, due to the fact that you're living through a polar excursion. And let's do a cosmology segment. This one will be pretty short and will not involve rolling any dice. By the way, we are streaming live to Twitch. It's twitch.tv/smAsho. And thanks to our Twitch viewers. And before I continue on, I just want to make sure that the stream is good to go. And it looks just fine. No need to roll any dice today, as we've got a Sky Scholar video to suggest that you watch. So Chablisky's star is an interesting star in that it has an extremely slow rotation. And the chemical composition of stars is very important when it comes to the world of cosmology. Why? Well, because the chemical composition of stars is very important in terms of what stellar behavior actually is. Where do the heavy elements come from? It's a pressing question when it comes to cosmology, and Dr. Robitaille is answering some of the said questions. So Dr. Pierre-Marie Robitaille, if you're not familiar with him, the Sky Scholar channel, go subscribe over there. Watch all of his videos. And Chablisky's star has some insane ideas around it. The idea that Okay, let me just backtrack a little bit. Chablisky's star is important because its extremely slow rotation allows us to get very distinct and detailed spectral lines. In other words, we can do a very accurate chemical analysis of what's going on the surface. And what's going on the surface are elements that are so exotic that they can't be explained by the standard model. That there are generation 1 and generation 2 stars, and you've got to have supernovae in order to have the heavy elements and so on. It's much more plausible that all stars are able to make all the elements, and they don't need a nuclear fusion dynamo core to do so. Here's a little clip. Let me move my mic.
Might use stars to store nuclear waste, a notion broached by Daniel Whitemeyer and David Wright as far back as 1980.
The idea that the exotic elements on Chablisky's star may be because Chablisky's star could be an alien waste dump site. Leave us a comment and let us know what you think of that insane idea. Is it a little bit more plausible that stars are able to make heavy elements on their surfaces, or is it more plausible that aliens have gone out of their way to drop their trash on stars? So check out Sky Scholar's latest video, Chablisky's star, the total denial of reality, aliens, undiscovered elements, and more. One other thing we're going to look at quick today on today's cosmology segment is the X-ray transient outbursts of Cygnus X3. Has it reached its pinnacle here around day 6 of the year 2021? Is that going to be the peak of the activity? Is it going to drop back down? Or will it go into an even higher energy state? Cygnus X3, otherwise known as the star Deneb, is a high-mass X-ray binary consisting of a very massive radio source orbiting a Wolf-Rayet star at relativistic speeds, and one of the jets of that massive radio source is pointed directly at you. One of the only known point sources for cosmic ray flux, Cygnus X3. If you want to follow the transients from that object, head to the Neil Gorell Swiftbat X-ray Observatory, type Control F, type in Sig space X-3, and you'll find it. Cygnus X3. And if you're not interested in it, Göbekli Tepe is oriented toward Deneb, the star associated with Cygnus X3. It's also the brightest intrinsic object visible in the Milky Way galaxy. That's today's cosmology segment. And if you want to talk more cosmology, head to smAsho.com, scroll down here, and click on the smAsho forum. There's a whole cosmology forum there. And check out our new link. You'll find a new link here at smAsho.com, smAsho merch. What's in the smAsho merch shop? Well, only 2 designs now, but there's about to be a third. And one has to do with the definition of the verb Google, and the other one has to do with the dimension of the year, hell. So perhaps go check those out if you'd like to pick up the extremely high-quality prints. Head to smAsho.com and you can link to our new merch shop there, as well as the Teespring store. So those are still there, but expect a revamp soon. Again, we are streaming live to Twitch. It's twitch.tv/smAsho. If you're viewing on YouTube, the video can't continue, and the place will continue to burn until you press like and subscribe. So press like, press subscribe, press the share button. Share with your friends, share with your foes, share with your science noobs and science pros before the place goes up in flames. And help us to continue to exist. Again, the video can't continue until you press like and subscribe and share. Thanks to our new subscribers, in all seriousness, over on YouTube. YouTube.com/smAsho. Check out our playlists as well. If you haven't seen those, there are all kinds of subjects besides the daily space weather. Also, follow me on Twitter. Here's an actual screenshot from yesterday's daily space weather video live premiere. And thanks to everybody who views that. Twitter.com/smAsho for additional content. Did you hear about the new executive order about China? China. Joe Biden has signed an executive order stopping us from calling you the China virus. No more China virus, okay? Okay. Have you learned how to say China yet? China. China. C-H-I-D-A. China. And I'm afraid I'm going to have to ask you to leave the set, COVID. Man, that thing really blows sometimes. Twitter.com/smAsho. You can find all of our social media at smAshomash.com. Thanks to our BitChute viewers as well. Thanks to our patrons, the true source of funding for the content. Please consider funding us at patreon.com/smAshomash. We need your help to keep these videos free and publicly visible, as we're paid just this side of nothing to put them on YouTube. So again, get involved, visit our links, check out the merch, consider becoming a patron, patreon.com/smAshomash. Thanks, patrons. You remain the main source of funding for the content. And look for more exclusive content coming soon at you patrons. Next, we're looking at just a diagram here of the atmospheric layers, and that F on the right there, that red F to the right of visible and IR electromagnetic radiation penetration into the troposphere. That red F is where the GOES 16 makes its measurements, so we show it daily to give you folks an idea of where the GOES 16 is located. There's where it's measuring its X-ray flux, and we don't see any major flares. The likelihood of some solar flares has gone up a little bit, as we've seen some new sunspots form. We don't see any proton strikes. No coronal mass ejections are currently on the proton flux list. And again, I think there's a coronal mass ejection happening as we make the video. We'll follow up later if there's an actual coronal mass ejection. Here's the GOES magnetometer, and you can see pretty spiky readings here. The Earth is about to slip back into the South Pole current sheet. So by the time we make tomorrow's daily space weather video, the Earth will be in the South Pole current sheet. So here we are on the Gong 2 data, part of the National Sunspot Observatory, and you can see the Earth is currently in this green current sheet, which is North Pole oriented. By tomorrow, we'll be in the South Pole one. And those sunspots in the Northern Hemisphere make it more likely. Keep in mind that data is 1 hour and 6 minutes old and can change with absolutely no warning. Here's a line of sight coronal hole plot. This also shows you the sun's B field in blue. Significant coronal hole rotating back into the Earth-facing zone, which will be geo-effective in about 4 days. Here's another version of the line-of-sight plot. It also shows you the poloidal fields and the solar magnetogram. And you can see those areas of magnetic organization in the north. Last but not least, here is the solar coronal magnetic field plot, the magnetic field plot of the sun's corona. It'll show you closed potential field surface source lines in pink and open ones in either purple or black, depending on where they're located. Polar coronal holes shown in black. Non-polar coronal holes shown in purple. And let's continue on to look at the ionosphere. As the electron flux has increased, so we're expecting a less anomalous-looking ionosphere, and indeed we've got it. So we're at more normal levels of electron flux here, in fact approaching warning levels, and we're expected to see them go even higher. We'll talk about it momentarily. There's the current image from 9:45 Universal Time, and you can see this increased forecast. These green squares rather, those are the electron flux forecasts from NOAA. And I would not argue with those forecasts. We could see some significant GPS errors, satellite drag, etc. as a result of that. I won't refute that forecast. So here you can see the current levels, and I would offer up a guess that we're going to get into warning levels here, which occur at 1,000 pulse flux units. And if you were a patron, you would probably already know this as we send out alerts. Here is the total electron content forecast. This shows you basically the density of the inner Van Allen belt, the density of electrons between your GPS handset and your GPS satellite, which orbits in a geosynchronous orbit at about 12,500 miles of altitude. And we see a more organized electron flux here, and you can expect big errors around the equator at noon, and less anomalies here as we get a more organized electron flux. Here's the 1-year chart of the electron flux to put it all in context. And next we're going to do some meteorological stuff. Here are the jet streams of the Western world. Some extreme bends in the jet stream there over Western South America, I might add, as well as a tripled up jet stream over the Atlantic Ocean. Here are the jets of the East, the Eastern world's jet streams. And before we move on to more meteorological stuff, let's talk about the Svedrup Glacier. So, there's the Svedrup Glacier. You can see that, at least according to the current Google Maps image, it extends all the way into the sea. Does it look like it's receding to you? If it was receding, it would be going like this, and you'd see rock exposed instead of the glacier. So, there's a scary, spooky article on SciTech Daily about the Svedrup Glacier. Svedrup Glacier. And we're going to talk briefly about how hot the planet is, because global warming is a very, very crucial thing to really be worried about. So let me just pull up this SciTech Daily article. Apparently the ocean must be undermining the Svedrup Glacier. Right? Could it be? Okay, there was an article on here. Here we go. Warming seas are undercutting the Svedrup Glacier, right? Okay, well, here's the current situation. By the way, that's located over here west of Greenland in the Baffin Sea. And, well, I see sea ice there. So how could the ocean be undermining a glacier, one that's not receding? Now, this data is from the Danish Meteorological Institute. And you can look up sea ice thickness and volume right there. So there it is as of yesterday. And we're in the operating range here. This is on the low end, actually, of ice thickness and volume. But you can see Greenland is quite surrounded by ice. And I just wanted to show this graphic. This is from Global Cryosphere Watch. Look at the Pacific Ocean cold anomalies. And yes, we do have warm anomalies as well. But look at how much blue to red ratio there is. Apparently, and it's summer in the southern hemisphere, by the way, folks. Apparently the ocean is so hot that it's cold. Let's move on. Here's the GOES lightning mapper, and we see some lightning here over Mississippi and Alabama, and a little bit over Georgia. Here's a real-time lightning map. I like to use lightningmaps.org when I hear thunder. And we don't see any terrestrial lightning in the U.S., so we'll continue on to show the U.S. Doppler radar map. So there's a U.S. Doppler radar. New York and New England getting some snow continuing. And I drove through a variety of conditions yesterday, but I survived because I was prepared and I understand how to forecast. And we implore you, our viewer, to understand the physics for your own personal benefit. Check out the low pressure system off the coast of North Carolina. Significant low there. And this is what we're looking at here. This is the Euro forecast for snowfall. And that is through 1 p.m. tomorrow. So this is the snow increase expected. And we're expecting some heavy snows there in North Carolina and Western Virginia especially. So that's windy.com. That's the Euro forecast. Here's the GFS forecast on Tropical Tidbits. And there you can see that incredible amount of snow in Eastern California, as well as that is absolutely insane. So that's 1800 Universal Time, which would be 1 p.m. Eastern Time. And that's a Tropical Tidbits GFS forecast. Let's look at water vapor. Here's water vapor for the Americas. And here's me vanishing. And a great water map there, water vapor map there. Here is the cloud situation over the U.S. And there's an atmospheric river over the western portion of the country. Here it is in water vapor. It'll jump right out at you. Atmospheric river in the house, and dry air over the mid-Atlantic. Once again, there's the cloud layer. There's water vapor. And I would remind you once again to please press like and subscribe on YouTube, share with your friends, foes, science noobs, and science pros. Thanks to the SMASH team for tuning in. We've got a bonus of features. We're going to be showing you the solar intensitygram and the colorized magnetogram to show you those new sunspots, as well as 2797. So there's 2797. It looks like it might not even be a sunspot anymore. But these two up here, those showed ombre when we were doing show prep. Those are cycle 25 sunspots. And you can see the leading polarity is north, trailing polarity is south on both of those. And here's the intensitygram. Sunspot 2797 is still in existence. It's alpha class. And there's sunspot 2800 and possibly 2801, although this one has shrunk. That one, I think that one shrunk a little bit also since I did show prep. It could be named, it could be not. The main thing to look for is that coronal mass ejection that I talked about earlier. Don't be surprised to see it happen. And we'll go back to our HelioViewer movies to close things out. There's the 193 angstroms view. Great view of that southern coronal hole. And again, the activity looks like it's coming out of the southeast, so that's the place to keep an eye on. And when I say eye on, I think I already did that joke. Here's the northern hemisphere in 193 angstroms. And here it is in 131 angstroms. Another ionized iron state. I don't know exactly how many electrons that state of iron might have. You can find all that information at the SDO website. Here's 94 angstroms, one of my personal favorites, which is another UV emission spectral state of ionized iron. Here's 171 angstroms. And here's what's going on in the south, the southeast especially. We've skewed it a little bit to the east because, again, there's some filamentary activity going on down there. Not sure if that little dance at the end of the video there has ejected or not. It's really too early to tell. And here's an extreme close-up of some filaments that we saw prominently above the limb. And you can also see those filaments in the upper right In any case, thanks for tuning in. Remember, stare at the sun. Don't drink no matter how much the government drives you to drink. And if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Visit our links, and may that solar wind be at your back.